So hello, everyone. Welcome to this webinar in the Iliad webinar series. Today, we are going to talk about offshore wind energy and digital twins of the ocean. We have a very interesting panel with in the field experts working on offshore wind energy. In the field, I mean actually creating applications and services, digital twins, that will service offshore wind. My name is Bente Liljaby. I am the innovation manager and also responsible for engagement in Iliad. And today I will show you the program. And first and foremost, we will also introduce you very briefly to Iliad and remind us what digital twins are. So I will start by then sharing my screen. And like this. So, sorry. This webinar will then last 1.5 hours. We will hear 3 presentations, and then we will have a discussion. So warm up and be ready to ask the speakers questions and engage in the dialogue. So first, as I said, this is the agenda. I will introduce you to Iliad and to digital twins. Then we go on with interactive multiphysics digital twin for naval application by Martin Courgen. And then we will move on to yet another wind farm operation and maintenance by Ricardo Pereira from Wewek, Portuguese company. And then last but not least, the Iliad Blue Tech transfer tool with focus this time on resources for project development and commercialization in the renewable energy domain by Sofia Parzadanian from the American University of Armenia, and then a discussion by all of us. So, see, I will admit some people while I move on to the next. First, a reminder of what digital twins are. So this is the natural identical twins to humans, as you can say. Actually, it's my father and my uncle. I bring them here because I will use this to illustrate that there's a big difference between identical twins by nature and digital twins. They are the identical twins like my father. They were so much alike when they were kids, but they grew older, grew more different as they grew older. Digital twins of the ocean, digital twins are digital replica of nature, of the ocean, but as they grow older, they become more and more alike the other. So the digital version of the ocean will become more like the physical ocean. So there are some definitions eventually has been developed. As we started the Iliad project, it was not so clear, but the International Standardization Organization, ISO, have landed on this definition, as you see here on the screen. It's a digital representation of a target entity with data connections that enables convergence between the physical and digital states at an appropriate rate of synchronization. So this means that as we get more information in forms of data about the ocean or what we do in the ocean, the more identical or more alike they will become. And it can be real-time data that is feeding constantly into your digital replica, or it can be also other types of historical data as you get access to them, etc. The synchronization can happen at different rates. In Iliad, we are, of course, using this definition, but we are also focusing on the interoperability of twins within twins and also between twins, and we will come back to that. And of course, all of the twins are data intensive, and it's a cost-effective way that we are approaching this. So interoperable and federated systems. So that's a short introduction to the definition. And yet another reminder of something you probably know, have seen before, what is a applications and service data pipeline, is that you start to collect your data, acquire the data through sensors or other repositories, and then you store the data and prepare them so that you can do analysis on them and create services and applications. Finally, when you have done the algorithms, the modeling, etc., you need to present it in a way that the user can actually make use of. So it depends on what kind of user it is. It can be a panel, it could be an animation, a visual 3D visualization. It depends on the end users. And I'm sure we will see some very nice examples of this today, actually, in the two twins that we are going to see, to study closer. This is a pipeline. You see here, those 4 steps are a pipeline for any service and application. What is special with a twin is that this goes into a loop. So once you have a model, you have done it once, you can run it again, or you can steadily increase, feed data into your system. So that's the digital twin version. In Iliad, we focus on thematic and local solutions. So the digital twins of the ocean in Iliad is actually solving concrete problems. And we have divided these problem areas into 12 thematic areas. Jellyfish swarm forecast, oil spill, plastic pollution, aquaculture, fisheries, harbor safety, etc. 12 different thematic areas, depending on what kind of activity that we are actually using digital twins to solve concrete problems with. And they are placed around in the area of Iliad, which is not only Europe, as you can see from this map. If you study it closely, we are also covering Africa and the Middle East. We are, in fact, 19 countries, 54 partners from these 19 countries. And the total budget is around 19 million euros, because this is an innovation action, and several of the partners are also investing, in addition, of course, to the European Union. So with that, I will stop sharing my screen. I'll look at who else I need to admit, and then we can start the program. So first up is Martin. Martin Cogen. He works at CEA, which is, I will say actually the word, and this is interesting because he's working in the Commissariat à l'énergie atomique et aux énergies alternatives. So it's a directorate, if you like, in France that is responsible for atomic energy and also renewable energy. So Martin, you are an expert on optical physics from Canada, actually. And you've been working in Geneva, in Mira Lab, and doing physical simulations of video games industry. And now you are working with CEA on helping optimizing the maintenance of also of offshore wind. So Martin, the floor is yours.
Yes, among other things. Thank you. Hello, everybody. So I'm going to be talking about interactive multiphysics digital twin for naval application or offshore subsea. And so I like starting with this slide because here I have a little graph of well, on the vertical axis, I have the CPU time, so how much time it takes to compute. On the horizontal axis, I have the accuracy. Now, when you want to do physics simulation for whatever type of application, you have to understand what you want to be using that for and what is required, what type of simulation tool you will need. So here we can see on the upper right all the offline simulation tool. This is a bit of the reference. Those will offer a very good result. it takes the time it takes to obtain that result, but the time is not the objective. The time is to get good result, right? On the other extremity, lower left, you have less realistic physics, so typically used for video games. A lot of people will start using those physics engine for more than video games, like doing serious games, maybe some training. The If you want to do prototyping, you won't be able to make any decision based on those simulations because this is not accurate enough. Well, as a matter of fact, we are just here. This is the XDE. This is the physics engine that we're working on at CEA, which is offering the accuracy of the offline simulation tools while still being interactive. Being interactive means you can have the human in the loop. So if you want to have to be able to train well, to have the operator validating an operation or to train him, you have to have an interactive physics. In here, in this arrow, I just wanted to picture that we are using, well, what we call model reduction. It can be using neural network or other type of method to try to pull some result from the offline simulation tool and to restitute that into an interactive simulation tool. I will speak about that a little more later. Um, so here in the work that we've done that was connected with Iliad, well, we've been working for some time with some stakeholder, and the idea is really to do some virtual prototyping, to do some risk analysis. So those stakeholders, they were in a situation where there are some engineers designing a mission, designing a machine, a tool, and they had on the other hand the operator using them in the middle of the ocean. And for the longest time, those people were not talking to each other. So when you get to the middle of the ocean with some design that's been done by someone who's never been to the middle of the ocean, you may end up with some problem. So the idea was to use simulation to be able to bring those people around the same table so that the operator could actually, using the simulator, try the concept and validate it or not, and be able to iterate for a little while so that they can come up with a solution with which everybody's happy. So we started like a while ago, like with some simple like vessel on the ocean and adding more and more features with time to get more and more sophisticated simulation. And then in Iliad, we started to add this connection with the digital twin of the ocean. So when you want to simulate an operation, an offshore operation, well, you have to deal with environmental conditions. And the more realistic those are, the better the simulation will be, the more realistic it will be. So we've been working on some connectors with like Iliad's data so that we could get the wind, the current, the sea state into our simulation. And we've been also working at and adding, well, coupled seakeeping. I'll speak more about that in a moment, and low spin maneuverability. So in this example, the idea is to, well, this design, this is a design. This is not a machine that exists at the moment. The idea for the stakeholder is to be able to build a machine, a system able to do a maintenance operation on the floating wind turbine on site without having to unhook the wind turbine, bring it to the port, fix it, and bring it back. So this is quite a challenging operation because like this is quite like 120 meters in the air. Everything is moving, everything is flexing. So the design is tricky, and our objective is to simulate the design to see if it's gonna work or not before to build. So this is very really virtual prototyping. So for all the hydrodynamics aspect, we've been what we do here, we use like a Diodor or like you have some offline simulation tools that are able to simulate a floating object on the ocean, well, on the sea state. It's really a train wave. So we do the simulation in the offline simulation tool, and this allows us to obtain the RIO. I don't know if you're familiar with that. This is for first order term of the behavior of the ship on the ocean, and the QTF, which is the second order term. So which will so if your ship is floating for a while, it's gonna drift slowly, and this is the second order term. And now we've been working on adding another complexity, which is the coupling. So when this ship gets close to this other floating when two floating structure get close to each other, they will affect each other. So they will move differently. And when you want to latch this lifting system to the wind turbine, it's gonna be something important to consider. So we've been adding like this coupling between the two structure, and this is an example of like the comparison of what we get in the with the model reduction compared to the original Diodor, and we can see no difference. So the model reduction is very good. And here we within all the partner of the Iliad project, we've been working with the geomachine team so that we are able to go on the map, select the location of the operation, the time of the operation, or the time we'd like to do it, and then to pull all the information, namely like the wave direction, the period, the height, the wind, etc., and to transform that into a train wave that we need, and to introduce that directly into our simulator. So this is quite interesting to do that. So yeah, as I said, the pilot's main focus is to simulate this scenario. So there is like two tricky sequences that we are really focusing our attention on. It is the latching of the lifting system to the wind turbine base, and the blade replacement. So we have like so for the first one, we have been implementing this low speed maneuverability and we have to simulate all the fenders and all the little device that will make the connection between the two structures solid. And the second tricky part is the blade replacement, where you are like high up in the air, everything is flexing, everything is moving, and you have like to insert the blade inside the rotor within the precision of less than 1 centimeter. And you have those two tripods there that will try to maintain the relative position of the blade with the rotor based on some sensors. And yeah, so we are going to be letting the constructor testing different controllers for the control command for that system so that it is as efficient as possible. So as you can see, this is some pretty tricky simulation. We're going very far into the accuracy, into the validation process, so that we can really shorter the development time, the design and development time of such a system. Yeah. So the conclusion, I will just repeat what I just said. So the pilot's objective was to really couple some simulation system to the Iliad's digital twin to try to get the best out of both. It is being used to validate, prototype new hardware created especially for this specific task. And the real objective is really for a stakeholder to reduce the cost, reduce the risk. That's working out well. And thanks to Iliad's Ocean Twin to provide us this data that we needed. Thank you.
Thank you very much, Martin. Indeed, you really showed how demanding the context of maintenance and activities in general is offshore. It's a complicated situation, and I'm very happy to see that physics is also helping. With my background from astrophysics, I can always appreciate some physics. Anyways, we will come back to questions for you, Martin, later. We are jumping then directly over to Ricardo. So Ricardo, he works for Wavec and has been working on renewable energy for quite some time. Aerodynamics is one of his areas. He has both a leg in the industry, so in Wavec, but also in the academic world as a professor and teacher at Delft. I think you worked at U Delft, among others. And you are looking also at offshore, of course, offshore energy to optimize, to see how you can optimize the maintenance processes. So Ricardo, the floor is yours.
Hello, everybody. Hi, can you hear me fine?
Yes.
All good?
Yeah.
Yes. Okay. So, hello, welcome. Thank you for this opportunity. Before I say anything else, my name is Ricardo Pereira, like Bent mentioned. So, also thank you for the introduction. Now, what we are here for. Oh. Sorry, there was a pop-up from Zoom. What we are here for is to talk a little bit today about our digital twin that we have been developing here at Wavec within the context of the Iliad project. So this is more or less what we are discussing. It is also within renewable energies, and more specifically, it is geared at wind farms, offshore wind farms, and more specifically, it is geared towards planning of maintenance of offshore wind. I will tell you a little bit about that. Regarding this presentation, so first, just a little bit of an introduction, such that you can have some background on this guy. And then something about motivation and, let's say, theoretical background. Basically, why do we care about the problem of maintenance for offshore wind? And this is where it maybe it's a little bit surprising, because with our pilot, we are combining two different aspects. Let's say one is wind farm maintenance and the scheduling of the maintenance, and also aerodynamics. This is more actually my background, let's say, my original, let's say, formation. So they are related, and we will talk about that. Then we introduce the pilot itself that we will be talking about, namely its acronym, which is STOMP, for short-term operation maintenance planning. So it's why it's STOMP. It's a nice acronym. And then following that, we will talk a little bit about the STOMP within the Iliad context. So what is environment? And then depending on how much time we have, we can do a small demonstration. So I have a video here. Maybe I won't play the video. Maybe I just play with the pilot itself a little bit, and you can see it moving, let's say. And then we can also talk a little bit. Then we will also talk a little bit about marketplace and visualization. This means where you can use where you can, let's say, have access to our pilot, and also something regarding visualization, a little bit in line with what Martin, the previous speaker, was showing. And finally, we go for some, outlook and conclusions. So first, I guess I can say something about myself. Indeed, like Bente said, I did study at the TU Delft. I did also work at the TU Delft, but it was up until 2021. So now what I where I still am very much connected with academia, but it is at Lisbon University, which is where I'm from originally. Like I said, my background is mostly aerodynamics, but also structures and control. So more of a physics applied to offshore wind background. And I've been at WAVEC already for over 2 years. And within that, I am doing project management, also more supervision and proposal acquisition type of stuff. As for WAVEC, I mean, this is not a pitch about WAVEC. I'll just say that it's great and I love working here. But it is an institute slash company founded some 20 years ago. Initially, it was doing WAVEC. This is the logo here. WAVEC was originally focusing on wave energy, hence the name. It was the Wave Energy Conversion Center. But for a number of reasons, wave energy didn't really pick up as people thought it would. So most of what we do now is geared towards wind, actually, even though we have other projects, namely in tidal energy, floating PV, and also regarding more, let's say, environmental projects, for example, including aquaculture, nature inclusive designs, etc. And within that, we do all sorts of studies, engineering and operations, but also economics and policy. So all, let's say, a broad range of studies. So with that in mind, now we start a little bit with the motivation for developing this twin, this digital twin, which deals with maintenance. So why, first of all, why do we care about this? So why do we care about maintenance of offshore wind farms? Well, first of all, there is a rapidly increasing share of renewable energy and offshore wind specifically in the energy mix in the European Union. Not only in the European Union, but especially in the European Union. And from this increased wind energy share, offshore wind is really picking up for a number of reasons. Of course, one of the main ones is that there is more space offshore compared to on land, which is already somewhat crowded. But the main reason why we care about maintenance of offshore wind farms is what I put here in bold. It's because if you look at the cost of energy associated with a floating offshore wind farm, it amounts to more than 1/3. So more than 1/3 of the costs arises from the costs associated with the operation maintenance activities. So it's clear that this is an aspect which can improve significantly. And then there are more reasons to care about this, namely because since we are going for, the trend is to go for larger farms, and this allows for more type of diverse O&M stands for operation and maintenance. So it allows for more diverse O&M strategy. So there are more degrees of freedom. Of course, if you have more turbines, you can think about more ways to make interventions. And you can even think about, optimizing using several wind farms. You can think that the resources that you are using, namely the vessels, so the ships that are required to do the maintenance, may be shared by more than one wind farm. And finally, it's also expected that, as we are disseminating the digital twins, we have more accurate monitoring and control. That's the whole idea of a digital twin, is to really have a digital replica, which ideally you can, let's say, provide inputs and effectively change the operational state of your asset, of your system. And this can increase the asset, the effectiveness of the management of the asset. So these are the, let's say, the reason why we care about operation and maintenance, to begin with. Now, operation and maintenance in offshore wind farms. There is, I'll just briefly go over this slide, just that you have an idea. So usually we talk about, preventive maintenance and corrective maintenance. It's a little bit like you are used to in your car or in your whatever equipment that you have. The corrective maintenance, we also call it repair. It means when you do an intervention because your car broke down and then you have to do something, you need to repair it. And you have the preventive maintenance, which we can refer to as service, which, as the name implies, is the maintenance you do before it breaks. So, for example, changing the oil or changing your brakes, for example. So the things that you do, before failure has occurred. Yeah, and there are more than one, let's say, strategy to go about this. And also important to realize here is this idea of the availability. So availability just meaning, how what's the fraction of time that your turbine is or that your farm is operational. But there is a theoretical availability and then the real availability or the actual availability, which also depends on the accessibility of the site. So what do I mean accessibility of the site? If you're thinking about offshore farms, of course, it's easy to understand that if you have a very rough sea, if you have very bad weather conditions, then it is not safe to go and do maintenance operations. So as such, the availability is also affected by the accessibility. Again, accessibility meaning how easy it is to actually go into the site and do some maintenance. And usually, we talk about different time horizons. We talk about, operational, that's within a few days, tactical within a few months, and strategic, that's within a few years. And what we will do within Stomp, so Stomp, our pilot is short term. So short term means a couple of days. So actually, within this classification, Stomp would be dedicated to operational maintenance, let's call it. Okay, now something about wind farm aerodynamics. I guess most of the people here are not really experts on aerodynamics, so I will try to keep it brief. First, I have this picture here. I guess some of you have seen it, not everybody. This picture here on the left, it's a very famous picture, actually. It's the most infamous picture in offshore wind energy. And the reason why I show you this, it's because we can really see the wake effect. So what do I mean, wake effect? Well, as we can understand, wind turbines, to put it briefly, they are extracting energy from the wind. That's why they are wind turbines, which means that they necessarily they will change the region of the flow that is behind the machine. Now, this region behind the machine, we call it downstream because it's downstream of the machine. And what happens in this region, we call it the wake, is that there is a decreased velocity, of course, because you're extracting kinetic energy, so the velocity of the wind decreases, and there is an increase of turbulence because there is an interaction, let's say, between the blades, the turbine blades, turbine rotor, and the air itself. So this leads to an added turbulence level. And for it, just to have an idea, the length, so the length over which these wakes are present can be up to 10 or even 20 diameters. Let's say, of the rotor, let's say, rotor diameter. So what this means is if you consider that we are already using 200-meter diameter rotors, then easily we can have wakes that are felt up to 4 kilometers. So that you have an idea, 4 kilometers downstream of a turbine, of an large offshore wind turbine, you could still feel the wakes. So clearly, it is something that we must we must care when we are thinking about offshore wind farms, mostly thinking about the design. Now this picture here, I'll just getting back to it. We can see, and if you can see, there is, for example, the wind was coming in this direction. Can you see my arrow? Can you see the arrow, my pointer?
Yes, yes.
Yes?
Ricardo,
Okay.
yeah.
So imagine that you have the wind coming from this direction, and this is what you would have. And you see all the turbines that are there in the back. So these are all, we would say, in the wake of this first one. Now, usually we cannot see the wakes this well. Usually, it's all transparent. But just in this case, there was a very special day with very special pressure, temperature, and moisture conditions, which made it so that the wake was visible clearly. But these conditions do not happen all the time. In fact, when you are designing a wind farm, obviously you will try to uh, to avoid in as much as possible that the row of the machines is aligned with the wind direction. So we never put the row of the machines aligned with the dominant wind direction. We always make it such that it is, let's say, unlikely this type of situation. Just to give you an idea. Well, there are a lot of lots of information here. I'll just try to pick what's most important. First, why do we care? Well, look, because here on the bottom, that's a good figure. So what we have here is the power that is produced by turbines along a certain row. So, for example, you would take this row of turbines, I'm putting here, take each of these dots represents a turbine there. And if I take a longer row, then this on the y-axis here, we're showing the power output. And then we see that, for subsequent machines, you have less and less power. The effective power that you have will depend a lot on many things, namely on the wind direction and on the spacing between the turbines. So within the same farm, of course, we have two examples with these two arrows here. If the wind comes from this direction, this is the spacing. But if the wind would be more in a diagonal direction, this would be the relevant spacing there. So of course, spacing directly plays a role. And we're showing here, with the different colors from green to red to blue. So you always produce less power, but the amount of the decrease in power, it's related with many factors. And what we're showing here is the impact of we call atmospheric stability. So for different days, different seasons, we have different levels of what we call stability, which is essentially related with the temperature gradients within the atmosphere. Now, okay, this is very nice, but how exactly do we include this, and what's the relevance for our pilot? Well, we are showing here a little bit the reasoning for that. So first of all, on this top figure on the right, I'm just showing what we call a power curve. So this means how much power is produced, that's on the y-axis, for a given wind speed. So generally speaking, larger wind speed, you produce more power up to a certain value, after which then you are at rated power. Sorry. Okay. As I mentioned before, the wake effects lead to decreased wind speeds and higher turbulence intensities at the downstream machines. And what the connection here between the wake effects and the operation and maintenance scheduling is that you can actually select the turbines within a certain wind farm to maintain, considering the power curve and the wind direction. So what do I mean here? Look, imagine if you have the wind here direction coming from 0 degrees, so from the top here. Just a second. If you have the wind coming from the north here or from the top, then you would probably first want to do maintenance on this turbine here, the turbine that is further downstream. Why? Well, because you would already get little power on that machine anyway, because it is, downstream. So if you were to maintain, if you could choose which turbine you would do the maintenance on, you would do on this. So that's one. So that's the wind direction influence. And the other is, of course, the power curve. What does it mean? If you have a very low wind speed, look, you produce very little power. of course. So this would also mean that you would rather choose to do maintenance on days with very low wind speed. So this is the mechanism, let's say, which allows us to produce more power by incorporating the wake or the effects of the wakes in the operation and maintenance decision. Now, you don't have to believe me. You can read this article to see where it was demonstrated. So the potential in short-term planning, so kind of 3-day weather forecast, is already demonstrated. I leave here the reference. And we also have understood, here is another reference, that over a long-term planning, so technical horizon, let's say over a whole year, this type of selection also is very promising, this type of maintenance strategy. And finally, I introduce our pilot STOMP. So what is the concept that we're doing here? So first of all, STOMP stands for short-term operation and maintenance planning. Like I said before, what does the digital twin do? It combines the weather forecasts, so looks at the following 3 days, and it combines the vessel fleet availability, so which vessels are available and what's the parameters of its vessel, namely the fuel costs, the CO2 emission, for example, the time it takes that it is ready to go, let's say, mobilization time we call it, etc. It also takes into STOMP also takes into account the offshore wind farm characteristics, namely how many turbines, what's the orientation, the distance to shore, for example. All these things are considered. And what it does, STOMP will schedule the requested activities, so what you request that is performed, while considering the vessel safety limits and the wake effects. So, like I mentioned before, you cannot go out to sea when you have very high wave heights or when you have very high wind speeds. So you need to consider the safety limits, and like I mentioned, the wake effects are also considered, again, to minimize the power loss. We call it the downtime losses. It's the loss of energy that you have because your turbine is down in the sense it's not producing power, because when you are doing the maintenance, of course, you can't actually produce power. And so these things are carried out, and what's the objective? So what does the STOMP do? So which is the objective, let's say, for the algorithm? Well, the objective is simply to minimize the costs that are associated with the preventive maintenance operations. And we focused on a case study with for the north of Portugal. Sorry, my phone is ringing. For the north of Portugal. And are these questions, have these questions popping up? Should I answer them now? Or sorry, Bent, I'm a bit lost. Or is
Yeah,
it to
no,
be?
ignore the rest of the audience can
Okay.
answer. You can continue. Sorry.
Okay.
Go ahead.
Okay, no problem. Okay. Yeah, like I said, we are doing yeah, we actually we started initially for this case in the north of Portugal, where there is already a wind farm, but actually in the current version of STOMP already we have more locations that are available and that are already being automatically updated. Yeah, so it makes it more interesting and usable, I would say. So, quickly moving to the second part, I had something about the components in terms of the work package of Iliad, but I guess this is not really relevant for this audience, so I will just skip it. I'll just leave it a couple of seconds in case somebody's curious to look at the architecture of our pilot. Maybe more interesting is this part, to tell you that the app is online and it's featured on the Iliad marketplace. And you can select it by going to the blue economy tab and then just press this green thing and then you go to STOMP. It is open, so it's open access, anybody can use it. The only thing is that we require a user account and the client subscription, which again is free. So if you want to use it, yeah, just go ahead, register, and send me an email In case you missed it, my email is here. So ricardo.pereira@wavec.org. So you can go ahead and use it. Now, I have a video here, but the video is maybe a little bit long. Okay, so this is a second slide, just inviting you to have a go. So if you prefer, you can do it right now. Scan this thing or take a picture, and then you can use it later. What you will need is you will need these input files. But again, if you want to use it, just send me an email and I'll send you these input files to start with. And also we have the detailed user guidelines, so to help you a little bit with using it, okay? Oh, I would say I can briefly go to the application and show you that it exists, so you can believe me a little bit more. I can show you. You can still see my screen, right?
Yes.
Yes, I guess so.
Yes.
So I can show you a little bit how it looks. Now I am on this is the link, stomp app wavec org. This is what you will get there. So you can just show you how it looks. You just you can start a new wind farm or use an old one. Just pick a project name, and then you need to select a couple of things, namely the turbines. We currently have 3 turbine models to choose from. 10 megawatt, 15 megawatt, and this is 8 megawatt. This is Siemens, this is Vestas, and this is just a generic turbine. So I'll go with the Vestas one. Select, and then you can see the power curve and the thrust curve of the machine. And then you need to select the layout. Again, I'm just going to choose a default layout. The layout it means here farm layout. So it means, where the XY coordinates of the turbine's positions. You need to choose also the vessels, so the vessel database, because it needs the stomp, needs to know, which vessels are available. So we have here the different names of the vessels. Fuel type, fuel density, how much fuel does it spend, how much CO2 does it emit, how many technicians can fit on board these vessels, also important, okay. And then you need to supply the activity list that you want to do, so basically which type of maintenance exactly do you want to do, okay. So in this case, I'm supplying this, I am requesting that Stomp will optimize for me 3 maintenance operations. They are all of the preventive type, and this is, 4-hour duration, contingency 2 hours to get the vessels. And these are the limits, the safety limits, like I said, wave height, wind speed, okay. And then because it's calculating, it's minimizing costs, so it needs to know what's the electricity price. So I'll just put here 10 cents per kilowatt hour, which is not terribly off, let's say, but it also depends on many things, okay? And then finally, you need to choose the weather forecast. And this, you can pick different locations. Like I said, now we have 2. So IPMA is indeed for the northwest of Portugal, and North Sea is somewhere close to the Borcelle wind farm in Belgium, for those of you that are aware. So you would pick all these things and then you create a project, okay? And then just to save you some time, I'll show you what it looks like in the end. Then you run, okay, you run the optimization, and then you have some results, okay. And in this case, I did it this morning. So the runtime, before you ask, the runtime, of course, depends on exactly how many operations you are considering, but it is a few minutes. So a few minutes, usually it's less than 10 minutes. But of course, if you choose 10 operations, it will take a few hours. For sure. Okay, but I can show you here the results a little bit. So in this case, we had these 3 operations, and I did it this morning, like I said, and it looks like the following 3 days. So today is the 15th of May. So, and it, let's say, scheduled these 3 operations at these times based on, the slots that would minimize the energy loss. Like I said before, taking into account the wakes and taking into account the turbine power curve. And finally, we have the breakdown of the costs here, and you can play with it. You can toggle and show, the costs just for the chartering, just for the associated with the downtime losses, etc. So there is an interactive, display to look at the costs, and you also receive an email with the results. So it's not only on the platform, is you also get an email with the output of the pilot. So this is, yeah, I think it was a little bit more efficient to show you the pilot, live. This was what I just told you, but it's yeah, the cost breakdown. Like I said, it also uses the weather forecast, namely the wave heights and the wind speed. The wave height is mostly to determine whether or not it's possible to do the maintenance, whereas the wind speed and the wind direction are really used to determine the best set of turbines and the best time slot. Then something about visualization. Well, yeah, this is well, a video already going on in the background. This was done in collaboration with the people from Work Package 6 with the Breda University. Yeah, that they have connected, let's say they provided this nice visualization, but it is not yet connected, let's say, to our pilot itself. So it is some things they already helped us out with, namely doing an animation of a CTV operation, but not yet for the with let's say connecting what you are seeing with the real weather on a specific location. This is something we would still like to do within the scope of the Iliad project. For future improvements, well, two main things. One is that we're planning to use machine learning to determine the typical weather days from historical data, basically clustering the data, the days into typical days, and also using a genetic algorithm for the optimization, which will allow to to do more maintenance operations in less time. So to make a little bit more efficient the use of the time there. And in the long term, let's say horizon, also like I mentioned before, there are promising studies already, and one of the ideas is to use the representative wind speed direction from statistical data, not necessarily the hourly data. Again, I leave here also some references where we talk more deeply or in more depth about these other topics. So my last slide, and in conclusion, indeed, offshore wind farms have a crucial part in the present and future energy supply in Europe, and operation maintenance plays a big cost. Operation maintenance cost plays a big part, which is in the end why we care about it. Our pilot has an innovative approach in combining the wind farm aerodynamics with the O&M activities as to decrease the operational costs. The application is already available on Marketplace. Like I said, you are more than welcome to use it. I will put again the QR code in a minute. And still improvements are expected soon, namely in a few weeks, particularly for the genetic algorithm. I mean, we already have a running version, it's just not on the server yet, and this will allow for more operations to be considered. So I just leave the slide here with the QR code, and with this I finish my presentation. I hope you enjoyed, and I'm open for your questions.
Thank you so much, Ricardo. It was great that you actually showed us how to use, showed us the interface. We are going to move fast forward, but if there are anyone who have questions concretely to these two presentations, these two different offshore wind digital twins, so to Martin or to Ricardo, please, I can answer a couple of questions right now before we move on to sustainability and the more commercialization part of it. So raise your hand, and I will make you give you the floor, or ask in the chat. You have no questions. I have a question for you, Ricardo. So you had you had list already, right? Alternatives when you in your user interface. Now, how easy is it to say adapt it to the North Atlantic, for instance, outside the coast of Norway? We are also contemplating and building offshore wind farms, but the conditions are slightly different than in around Portugal. So how adaptive? Could this tool be, can it be used anywhere, or any comments on that?
Yeah, sure. Yeah, no problem. What we need is an API which provides us the data, and to make it easy, we would request that the data is in the same format that the model already reads it in. You know, same number of columns, same number of lines, because what we need is the forecast. We need the weather forecast, and you know what the model really needs to know is the weather forecast, and you know we call it the characteristics of the wind farm, of the vessels, etc. But in terms of the for different locations, if you have different geographic locations, if you have the relevant information on the fleet and on the wind farm, then what you need is the weather forecast. And for the weather forecast, it is no problem. Like I said, if you have an API that gives us the data exactly like what's already in place, this is very easy. The other option that is a little bit less easy is we have an API, but we still need to further process the data. So of course that's yeah, it takes more to just make it into the right format, into the right you know, number of columns, number of lines, etc. But I can tell you, initially we were only doing for Portugal, and now we already have 2 locations, and one of them is obtained via an API that Hydromod, which is another partner in the Iliad consortium, kindly did for us. So they just supplied us with this API, and then it retrieves the data, you know, every day. So with the forecast is updated every day. So yeah, it is yeah, not complicated.
Yeah, okay, thank you. And I know, I see that Andrea is here, and I know that you have prepared questions, and maybe we can take those questions after Sophia, if that's okay with you. But Sophia has asked the floor also, so since you raised your hand, Sophia, before I give
Yeah.
you the floor for other purposes, so the floor is yours.
No, actually, I have a question for Ricardo. Ricardo, do you have any feedbacks from end users, clients, perhaps, on using your tool already?
You know, getting feedback is the hardest part, right?
Oh, it
We
was a tricky question, sorry.
no, so far we only have feedback from Iliad, from partners within the Iliad consortium. So we were supposed to have yeah, I'm not gonna say a partner, but yeah, we had agreed with one of the companies that we know quite well. It's RWE, which is a very big, I don't know if you know, a very, very big German company, and they are also doing some offshore wind farms. They did not reply, even though they said they would. And also with BayWa.re, we also had good contacts with their with one of their main people, this guy called Ricardo Rocha, actually, which is also a friend, let's say, of WAVEC. But yeah, people are, when it's time to give feedback, people are very busy. So is what I can tell. We only could force Iliad people to give feedback. Now, my hope is that in the Oceans Conference, which we are going to, and the week after we go to the WESC conference, which is even larger, is the Wind Energy Science Conference. There, I'm going to show a giant QR code, and I hope somebody can use it.
Yeah, and
I
thank you
don't
for
know.
that. Yeah, thank you for that question, Sophia. And I have noticed that those who are attending this webinar now, I think we can ask them to kindly give you some feedback, because there are many non-Iliad people here. So I guess since the topic is offshore wind, they might have a specific interest in the topic and be a good audience for you to check out the functionalities and check out Stomp, simply said. And we can come back to it. I want to come back to it, but now we want to move on to discuss sustainability, because following up on the question of Sophia is that when we are building these digital twins, it's not for free. It costs a lot in the investment, and but the purpose is to actually serve people and finding who would that be, and how can we find resources to do the proper beta testing, say, and actually get clients and end users benefit from these digital twins. So the commercialization part of it, or funding the different phases in the development of digital twins. And we have Sophia Partadian with us today, and she is working specifically on this at the American University of Armenia. She is an expert on this innovation process and blue tech part of the innovation pathway. She has worked on this for many years already and successfully supported hundreds, if not thousands, of SMEs, etc. So, Sophia, I give the floor to you to introduce the blue tech transfer tool that you have been working on.
Thank you, Bente, for this introduction, and thank you for this opportunity. Actually, yes, we are working specifically to develop a tool for scientists and project managers, project leads, that will help, we believe that will help them to move projects towards commercialization, market and user and clients. This is actually a kind of one-stop shop of different various resources that project may need to develop further. And actually now I'm working on adding AI tools, various AI tools to the database of resources we already have. I used one of them to create, actually from my presentation, a video that I will show you in a few seconds. In this video will walk you through the concept, structure, and design of Blue Tech Transfer tool, and show you content that is already there for the renewable energy domain. After the video, I will show you actually the website, the tool. So you really will not have to believe me. You will be able to see and perhaps use this tool. Now I will launch the video, and please let me know if you will not see and hear it in a moment.
First of all, thank you for taking time and joining us today. Our goal is to create a tool for scientists, researchers, project leads, and developers that is designed to provide them with the information about resources available for their project's development, commercialization, and scaling up. The tool is called Blue Tech Transfer, as it is relevant for the blue economy industries, such as marine living resources, marine non-living resources, marine renewable energy, desalination, maritime transport, coastal tourism, seafood processing, biotechnology, port activities, digital services related to ocean. In this presentation, we will walk you through the design and structure of the website and explore its key features. First of all, what type of resources are available in Blue Tech Transfer website? We are aware that today there are plenty of resources for projects development. You may need funding for your research development, finance for your business development, startup support services such as incubation programs for projects around idea stage, acceleration programs, as you already have minimum viable product and are probably first clients. Mentorship and coaching can help you get experienced guidance from industry experts. Even if your service or product is free, it is still worth learn how intellectual property rights can be protected through free consultations organized by EU or national project support ecosystem. Perhaps one of the most critical bottlenecks in projects development are feedbacks from potential end users' clients. Access to specific data and technical infrastructure is also considered to be a resource for projects development. Key question is, how are you supposed to get information about all these types of resources? Of course, we have Google, we have ChatGPT. Even before Google and ChatGPT, we had rumor mill, but all those ways to get information are pretty much time-consuming ones. You need time to verify whatever you will get from Google, GPT, and especially rumor mill. Sure, the main question is, how does the database of resources look like? Today, the resource database includes more than 200 different resources for blue economy projects. Resources for projects focused on aquaculture, fisheries, environmental protection, renewable energy domains are already available on the website. The resource database is constantly verified and updated with new resources, as well as no longer active resources are removed from the database. In the chat, you can write to us what resources for the development of your projects you use or used. If these resources are not currently in the database, we will add them. So, the Iliad Blue Tech Transfer is a specific one-stop shop with verified and consolidated information on all types of resources available for your project. Through a series of questions, the system will identify key characteristics of your project that it needs to show you the resources available for your project. Let's see how it works. The link to the website is in the chat, or you can use the QR code you've seen on the screen. The first thing you will see is a few simple questions about who you are and where you are from. This is important because the Blue Tech Transfer tool is loaded with resources at the national and EU levels. After you fill in your first name, last name, email address, country, and organization, the system will ask you some questions about your project. First of all, what do you need? Funding for research development, funding for business development, startup services, consultation about the intellectual property rights, feedback from potential end users or clients, or access to specific data or technical infrastructure. Multiple choice is available for this question. Another important question is, what industry is your project related to? Answering this question, you give the necessary information to the system to identify potential early adopters and clients. What is technology readiness level of your project? Most of resources are designed for a certain technology readiness level. Do you already have a prototype and minimum viable product? And have you taken any steps to protect your intellectual property? What is considered to be the result of your project? Will it be product that is manufactured or software service? Once the system has received answers to the questions we just went over, Blue Tech Transfer tool will be able to generate a list of resources available for your project with a brief description and links to more detailed information. Each green button is clickable and will redirect you to the resources website. In the case of startup support services, such as incubation and acceleration programs or investment funds, you will usually receive a direct link to apply or an email address for a contact person. How it will look like you can see on this slide. And on this one. As you see on this slide, there are around 50 resources for projects developing solutions for marine renewables. The number of available resources increases as technology reaches greater maturity. This trend will be relevant for each domain. It is important to note that potential customers and potential customer associations are included in the resources. This is done because it is especially important for innovative projects to involve potential end users in the co-design process as early as possible. Let's go through these resources in a little more detail. For projects in the earliest stages of technological readiness, funding is available through the European Innovation Council's Pathfinder program. Up to €3 million are available to take projects to technology readiness level 4, where technology is validated in lab. This year deadline for applications is 21 of May. Next cutoff date will be in a year. Another EU opportunity is iDigital Speed Master Course for project leads on business development, access to finance, strategy and management. In the early stages of commercialization, research projects are often deeply intertwined with their founding teams comprising scientists and managers of the research process. However, while researchers excel in scientific discovery, they are often unfamiliar with the complexities of commercialization, including market validation, business strategy, and funding acquisition. Given this, the availability of high-quality incubation and acceleration programs tailored to researchers and scientists is a crucial driver of growth in the knowledge-based economy, particularly within the blue economy. Starting at technology readiness level 4, incubation programs become available in the list you see on your screens. There are 3. Blue Invest Readiness Assistance is an exclusive coaching program for high-potential EU startups and SMEs with innovative and sustainable products and solutions for the blue economy. Blue Invest Fundraising Assistance is coaching program to identify and connect with relevant investors and master the pitch. Impact Shakers Accelerator 6 months of masterclasses, coaching sessions, market research support, and €150,000 investment. All above mentioned opportunities are free of charge for participants. Starting from the technology readiness level 4, it is preferable to start a dialogue with potential clients or end users and engage them into co-design process. The Blue Tech Transfer database includes Wind Europe is a European non-profit association that serves as the voice of the wind energy industry, actively promoting wind energy across Europe and globally. They represent a wide range of stakeholders in the wind energy value chain, including manufacturers, component suppliers, developers, and national wind energy associations. Integrated Wind Solutions, an emerging leader in integrated service for offshore wind. Subsea 7S, a Luxembourgish multinational services company involved in subsea engineering and construction, serving the offshore energy industry. RWE Renewables has separate research and development department. Of course, contacting industry leaders at the early stages of a project's development would be extremely ambitious to count on any deals, but it is an opportunity to establish cooperation or get feedback on a project at its early stage. Starting from technology readiness level 5, when the technology is validated in relevant environment, project becomes mature enough to be communicated with selected investment organizations, venture capital funds, and EAC accelerator opportunity. EAC accelerator opportunity is up to €2,500,000 in form of grant for innovation activities to take project to higher technology readiness levels. In 2025, deadline for applications is 1 October. In the list of venture capital funds, you can see two types of funds. The first type are funds focused on projects developing B2B software. Second type are funds focused finding projects developing solutions for the renewable energy domain. The pale blue dot fund specialization is projects developing software or hardware for ocean-related industries. Sounds extremely relevant, isn't it? The DOC Venture Capital Fund invests and provides industry expertise for projects developing technologies specifically for offshore energy sector. When the project has already reached the technology readiness level 8, it means that the system is complete and qualified. A much larger number of investment funds are ready to pay attention to the project. In addition, the Digital Open Innovation Factory program becomes available. Program includes up to €400,000 financial support, MBNTORING, and coaching services, support in attracting investors and customers. At the very latest level of technological readiness, the project already has access to serious acceleration programs, such as Catapult Ocean Accelerator. You can get from €150,000 up to €500,000 for ocean-related projects, working in the fields of food, transport, energy, natural assets, infrastructure, and new frontiers. Hands-on mentorship from top global subject matter experts, serial entrepreneurs, business leaders, and investors, as well as access to pilot customers, test environments, and real data. In addition, it is worth mentioning separately knowledge and innovation community in water, marine, and maritime sectors and ecosystems. WMM Maritime, the European Institute of Innovation and Technology, (ITE), is an organization that supports innovation and education by funding projects. In January 2025, the ITE launched a call for proposals to establish a new knowledge and innovation community, KIC, ITE Water ITE, focused on the water, marine, and maritime sectors and ecosystems, known as ITE Water. The indicative budget for this initiative is up to €700 million over a 15-year period. Project funding is expected to commence in 2027. Projects that are close to the commercialization stage will likely be able to receive support from KIC. Blue Tech Transfer Tool is available via link you see on your screen. QR code will take you to a very small survey, that's only 5 questions, and it is about the Iliad Blue Tech Transfer structure and design. Your answers will be used to improve Blue Tech Transfer Tool, make it more valuable, and more user-friendly tool for researchers and project leads from different European countries to identify resources available for their project's development. Your feedback may inspire us to work faster.